Okay, good afternoon all. Let's get into the session. So in today's session, we are going to see about introduction to PyTorch. Okay, hope my screen is visible. So this is going to be your last topic for machine learning. Okay, so what is PyTorch? So it is a dynamic tensor-based deep learning model which is used for some experimentation, research, and then production kind of thing. Mainly they use for high level deep learning projects. They will use this PyTorch concept. Okay, and another thing is it is an open source machine learning library and it mainly uses a GPU enabled replacement for NumPy. Okay, it will be more effective in creating and building neural networks. So that is one advantage. If you take already existing frameworks like TensorFlow and Thano means or other like Keras is there, like those are the most popular frameworks which are available for deep learning, right? But despite of all, PyTorch is nowadays being used in Google, Twitter, as well as Facebook AI research lab as well. Okay, that is one advantage of PyTorch. And then it highly utilizes the GPU facilities. Okay, if you are having GPU means it will be easily integrated with PyTorch to increase the performance. So that is another one advantage, and it is automatic computation of gradients. So we have seen some gradient error, right? So that and all can be automatically optimized. So that is another one thing, and we can use it for training and testing for new ideas as well. So that is what about PyTorch. And as I told, we are having a lot of libraries, but most popularly used nowadays are TensorFlow, Keras, as well as the PyTorch. Okay, then what will be the difference? We already seen TensorFlow, Keras integrated one, and then now I'm saying about PyTorch. So there should be some advantage of using PyTorch, right? Instead of going for TensorFlow and other library. So what are they are? In TensorFlow, the encoding computation graph is in this static structure. Okay, so that need to be run in a self-contained session. So like that only TensorFlow will run its program. Whereas in contrast to that, if you take PyTorch, it will dynamically implement the computational graph. Okay, that is one advantage. And then it will utilize the CPU support even more better, and it can able to switch from share. Okay, instead of saying like switch, we can say it as share. Okay, it will share the GPU and CPU resources evenly. Okay, that is another advantage. It is also supports multiple GPU as well. Okay, and another thing is in PyTorch, if you want to change the network behavior, even when it is running also you can able to change it with very less or no overhead. Whereas if you want to do the same thing in TensorFlow or other library means you have to rebuild the network from the scratch. Okay, that is why when we are doing it in TensorFlow, you might have seen when I'm asking you to change the epoch or any other things means I might have asked you to run from the network. Right. So because we have to rebuild the network from the scratch, then only it will properly execute our program. Okay, whereas in PyTorch, that is not necessary. Okay, that is another advantage. And one more, this major two, three things only making the PyTorch very famous, like dynamic behavior, flexibility, and another one advantage is the PyTorch is closely integrated with our Python language. Okay, it is completely written in Python language only, whereas in TensorFlow it is written in C++, right? So those are making this PyTorch unique. And uh, by default it will have some algorithm similar like TensorFlow, and then it will work like NumPy, how we can do from basic operations. Everything will be similar, okay, like NumPy array. So here, if you see the code means, if you are writing it numpy means it is taking like assume 10 line or 12 line in TensorFlow means it can be written in very less number of lines using PyTorch and with the same performance or even better performance because it is doing the dynamic computation, right? So that is why it is possible to do that. Okay, see here in the left hand side you can see the computation graph, right? So not a dynamic like single procedure means one by one it has to complete, whereas it is dynamic means if process are not related means it can do it at a time. Okay, that is another advantage. And if you want to install it in your Conda environment means you should give it as Conda install PyTorch -c PyTorch. Whereas in pip you are installing it in Ubuntu means pip3 install torch. If you are installing inside the Jupyter notebook by using pip means you can simply give pip install torch alone. Okay, so that is another one thing. So as I told, we mostly use this PyTorch for advanced projects or any other things only we will use. Since in your syllabus it has given we want to predict some unsupervised learning using TensorFlow, I have taken this particular example. Okay, and in previous class, I mean in the beginning of our classes, we have discussed that we can use deep learning concept for three different category, right? So one first what we use for detecting or recognizing things like image detection or face detection, object detection, moving object detection, like that. For detection purpose, we will use the deep learning concept. Second category, we will use them for prediction or classification, regression, that type of um, problem can be solved by another category. And third category will come under generation. Okay, we will try to generate new text, image, model, like that we are creating, right, which never exists before based on the data we have passed into our model. So here we are going to see the third method. So we are going to generate text, okay, by giving some text input to our model without like it is not going to be a supervised way. We are not going to say what you have to generate. Just we are going to pass the text, okay, and then we will ask our model to generate some sentence or para for us, okay, and we will try to predict how much it is able to generate the text. Okay, hope my collab is also visible. Uh, so this program, if you are running it in a local system, means it will take a lot of time to complete. Okay, because this needs some GPU support to make it faster. So that is why I've chosen Colab instead of using it in normal Jupyter notebook. And also PyTorch will be available in build. If it is not there, means then you can you know how to install Torch. Okay. So here the problem program which I have taken is going to generate some text for me, and I am going to pass the input text as Shakespeare's script is there, right? So that text format I will pass it into my data, and then finally I will try to generate some output. Like I want 100 words, 1,000 words, like that means it will automatically create one like drama kind of things. It will return it to me. Okay. So the code has been already written. I'm just going to explain one by one. So the RNN and then the model which I'm going to use is LSTM, which is a long short-term memory model. So both are not in your syllabus. Okay, when checking your syllabus, both are not there. But you just try to understand the concept alone. Okay, because it is completely unsupervised learning only. Okay, that is why I have taken this particular example. Okay, so what are all these steps we are going to go through is first we will import our model. Okay, and then we are passing the Shakespeare text data, and then we will encode it, and then one not encoding method we will try to do some encoding, and then we will train our model with some batches, and then we will create some LSTM model, and then after completing the training we will save the model. Okay, and then we will load the saved model, and then we will try to generate some prediction, okay, how it is generating. So these are the going to be our steps. Okay, so first is I will import all the packages we need. So first tensor is there, and then inside from the tensor, NN means neural network. Okay, like that only they have given. So in that neural network we have some functionals, so that I am specifying it as capital F. Okay, and then normal numpy matplotlib has been taken here. Okay, here I am not going to do any visualization, so may not be need this two lines also. Okay, so I will run this. Make sure if you are running this particular program means you should know how to upload it, and then make sure your runtime is having the GPU enabled or not. Okay, so I have imported everything, and in the next step I'm going to import the file. Okay, the text file. So initially whenever you are running, okay, I have already imported it. Okay, shakespeare.txt. Whenever you are running for first time, it will again and again ask for this particular file. Okay, otherwise it will throw error, because here it will be stored in the temporary time only. Okay, when you are rerunning the program it will automatically disappear. So I'm not running this line because already available. So directly I'm giving like with open Shakespeare text in read format I'm taking, and encoding I have told by default you will have some UTF-8 format. In case if this different format data you have taken means you should be specifying it. Okay, so all the text which is present in my Shakespeare.txt file, I have taken it in my text variable. Okay, so if I run and check my program means, so here it is completely giving me the raw data from 0 to 999. Okay, this many words are there. Okay, if I give only text like that means it will give me the raw data. If I put it in the print format means it will give me the actual data. Okay, this is how it is written in our text file. Okay, one first para, second para, like that it is written. And if you check the length of my text means it is having around like so many text data is there, like 54 lakhs of text, I mean inside the words I guess. Okay, are present inside our, did I started the recording? Okay, oh, present in my text file. Okay, and then I'm creating one encoding and decoding method. Okay, if you have seen uh, the older Python time, I have done one Shakespeare, sorry, Caesar's hyper program, right? Where in that what they have done, so one character is there means they will try to switch 2 3 character, and then they will find instead of A they will put it as C, like that they will convert, right? So here we are not going to do that. Instead, we are trying to replace the character with some number, okay, encoded number, or you can say. So here encoded number is nothing but the index number. Okay, so for this particular index number, this is my character. So because for processing purpose, it will be easy if it is in the numeric format, right? So that is why we are doing this shifting method, so that later on from the number we can easily convert to text format, right? One means A, two means B means, so easily we can convert. So for that purpose only we are going for encoding and decoding our entire text. So for that, first what I am doing is I am creating all characters, only the characters I am trying to take. Okay, so all characters is equal to set of text. So now if I check my length of all character means, so 84 characters is there. So here 84 means A to Z small, and again A to Z caps will be there, and then other symbols which we have used inside our text. Okay, to know that I am just printing all the characters. So if you see here means from A to Z is there. Okay, caps, and then some symbols is there. Even spacing also will be there. Okay, see here the slash n. Okay, that is also taken as one character, and then space. Okay, double quotes, single quotes, everything is taken as one character, and then other symbols which are present in our model. Okay, so totally we are having 84 characters. So it is easy to do decoding first, because what we are going to do, we are just going to match the index value and then the hope my now we are going to match the index value and the character value, right? So for that, I'm creating on dictionary. Okay, inside that enumerate all characters. So index value will become my key, and then the character will become my value. Okay, so I will run this. So if you check the decoder means, see here it has created the decoding. Okay, 0 means slash n, 1 means r, 2 means g, like that it has created one encoding format. So if you are running means you can get different encoding also. Why? Because initially we have taken it in set, right? So the set value will change, okay, when you the time of running. So one time if you are running means it will get 1 for r, another time it can get different value as well. Okay, and then I can also check the item. So key value pair I can see it in the tuple format. Okay, so 0 means slash and 1 means r, 2 means capital G. So like that it will create for all the 84 characters. So from this it is easy to create the encoding pattern. So you just have to reverse it. Okay, index and character in the decoder dot item, we are just converting, like instead of index and character we are making it as character and index. Okay, and then we are putting it in the dictionary format. So this is called as dictionary computation. Like we have seen, sorry, dictionary comprehension. We have seen list comprehension, right? So similar way we can do dictionary comprehension as well. And then if I check my encoder means, see, A means 39, B means 8, C means 64. Like that, it has created the encoding also. Okay. Similar way, what we are going to do, we are going to encode the entire text which is present in our file. Okay, for that, I'm converting into numpy array. Okay, encoded character for character in the text. Okay, each text it will take. Okay, from the text it will take each character and then it will encode it and then save it in an array format. Okay, so if I directly give encode text means uh, it will only show like this only. So I want to see like more information. So for that purpose, I'm giving it as like 500 text I want to see. Okay, so this is my encoded values for each character. Okay, so here if you see means 0 is there, 50, 50, 50 like that coming, right? So here all the 50s are nothing but the space. If you check the encoding method means for the space we might have got the value as 50. Okay, that is why we are getting here 50. Okay, when you are running this file, maybe you can get different number also. Okay, otherwise if I show here means here you can see, right? So this many spaces are there, and then one is as taken as character, and then another more spaces will be there, right? So likewise it will take. Okay. Mm. Then what we have to do, we have to do the one hot encoding method. Okay, so why we have to do this? Like previously, why we are doing this normalization or this type of encoding method to split the data as like multiple columns we will create, and whichever it is satisfying we will mark it as 1 and the remaining will be taken as 0, right? So for this purpose only we are doing this encode one not encoding method. Okay, so here if you see means, okay, uh, here if you see means we have created one uh, custom function. Okay, Inside that, here I have given encoded text and number unit character. So what is this? I will represent as, okay, here encoded text is nothing but the batch of encoded text, and then number union characters is the unique characters. Okay, so number of unique characters. So how this will be calculated? By finding the length of set of text. Okay, so like this it will try to find the unique characters, and then in the here what we are doing is we are creating one placeholder for zeros. Okay, based on the size. Here encoding text we have got as input, right? For that we are taking the size, and based on that size we are creating one empty framework, like we can say empty matrix with zeros in it. So I will specify it as, so we are creating placeholder for zeros. Okay, and in the next line we are converting the data type. Okay, it is important to convert, otherwise it will create some error in the later. So, converting, other people may have a problem hearing you. Am I audible? Hello? Okay, okay, thank you. Because I got some error, that's why I'm asking. Okay, okay, thank you. Okay, so here we are converting the data type, okay, for later use. We can also write some note also. Like this, in case if you are creating some custom function in your project or anything, means make sure you give some comments. Okay, why you have written this particular line, what this particular line is going to do. Okay, sometimes you might have got some error. To solve that error, you might have added 2 3 extra lines. Okay, but the person who is seeing for the first time may not know that because of some error only you have added those lines. They might have think this is some extra lines we can remove and run. In that case, it will create some error, right? So you can leave some note to the note in our code so that they will not make some mistake. Okay, so error may occur. Okay, and then in this particular line we are doing the okay, real I mean, one not encoding we are doing with the shape. Okay, and then we are passing the flattened value. Okay, so here what is actually happening is, wait. So whenever, I mean, whichever value is matching, so that will be given as 1, whereas other will become the 0. Okay, if A is present means A alone will be in 1, other encoder value will be in 0 format. That we have seen, right? For gender, everything we have done. So similar thing we are going to do here as well. Okay, index filled with 1, filled with ones at correct index location. Others will have 0. And then finally we will be reshaping, which should match with our batch shape. Okay, when we are doing some batch processing later, uh, this shape and the batch shape should match. So for that purpose we are reshaping it so that it will matches the batch shape. Okay, then finally we will return our encoded value. Okay, I will run this. Okay, so afterwards, so this is whenever we are getting on new text for prediction or anything, so we will pass the text for encoding, then the encoded value only we will use for prediction and other things. Okay, and then we are creating some training batches. So we need to create it to generate batches for characters along with the next character in the sequence as a label. Here we will not do the random picking of splitting the data into X and Y. Why? Because it should be in some sequential format, right? One word after what word should come, like in your text, I mean in your keypad when you're typing, whenever you add one word, okay, clicked one word, based on that it is changing the suggestion, right? So that all are in a sequential format only. So like that only we have to train our model, whereas in previous examples and all, we will randomly split our data. Okay, one part we will give it to training and another part we will give it for testing, right? So that type of random splitting should not happen here. Here we are doing the sequence splitting. We'll be like sequentially we will be splitting. Okay, for that I'm getting another one custom function, okay, that will generate my batches for me. Okay, here I'm using the encoded text. Okay, after encoding it will return to me, and then I'm taking some sample per batch. Okay, this all default arguments. If you want means you can change when you are passing the, I mean calling this particular function. Okay, by default I have given 10 batches and the sequence length should be 50. Okay. Mm, here if you see means encoded text means, so complete encoded text value, or you can say encoded text to match the batch process, and then batch size, so number of samples which you want to take. Okay, number of samples per batch. Okay, instead of passing one by one, if you are passing it as a batch means, I'm specifying like we have seen like 32, 64 like that you are giving means, it will entire value it will divide by 64 means 64 it will divide. So how many value you are getting, so it will round off the value and that many batches will be created. Okay, so that each batch it will pass new text which we have created. Okay, for training purpose. And then sequence length. So length of character unit. Length of character sequence. Okay. And then in this particular line, we are going to take the total number of character per batch. Okay. So sample per batch into sequence length. So we will get total number of batches, right? So total number of characters per batch. Okay, for example, if you are taking sample batch as 2 and the sequence is 50 means we are getting 10 character, okay, coming out per batch. Okay. Then in this particular line, we are counting number of available batches to make uh, prediction. Okay, for that uh, we are using the int method, okay, to get some round of value. Otherwise we will get it in some float value because we are doing some division, right? So length of encoder text will be in round of value, but whereas character per batch it may give you some float value. So to avoid that we are converting it into int format. Okay, so number of batches available to make prediction or anything you can say, and we are using int to round of the nearest integer. Okay, For this purpose only we are giving this particular line. And then finally, not finally, we have to cut off this particular. In some cases we are trying to round off, right? So which means point some value clash will be there. So to avoid that, we will do some cutoff, okay, so that the error can be avoided in this particular line. Okay, understood. Like 2.75 like that it's coming means we are converting into 2, right? Then 0.75 is still remaining, so that should be ignored. So for that purpose only we are giving this particular line. Okay, so cut off the end of encoded text. Okay, that will not fit evenly into our batch. Okay, and then we have to reshape our rows and columns based on our batch size. So reshaping the text into rows um, for the size of the batch. Okay, so after reshaping, we will go through the each row. Okay, by using the for loop, each row we will go through from 0 it will start and then until the end. So sequence length is, as we have mentioned here, 50, right? So 50 it will take and pass into our n value. Okay, so we will go through each row in array and then we will take the feature the character. Okay, so here y is like dummy. Okay, uh, same size of x we will try to take with empty 0 value. Okay, x only will have the actual feature. Okay, so grabbing the feature characters, whereas here simply we are creating some target. Okay, simply for giving like output kind of things, we are getting target and we are going to pass 1, which means I have told, right, we are going to predict the next character, what is going to be my next character. So for that same size of x I will take, and if hello world is there like that, assume or else wait, I will open the paint and show. If in x, okay, hello world is there means, or hello like that I will take, that will be splitted into separate character, right? H E like that assume. Then in y what we will do, we will do some shifting. Okay, so how we will shift is, so it will start with e, l, l, o, and w is there like that assume, then it will predict the w. So then you now you can able to understand whenever you are typing some text in your keyboard, I mean keypad, in your mobile phone, so it will try to match the next words, right? If I press h means based on your dictionary also it will change, but general words will be there, right? So if I give h means it will give multiple option, and when I am giving e, so it can predict like head, okay, or sheet, like that it will try to predict. When I'm giving again e means, okay, sorry, again e will not come, h l will come, right? So when I'm giving l means, okay, whichever matching, it can show like hell or hello, like that. Based on each value I'm passing, it will change its prediction. Okay, for that purpose only we are giving the y. Okay, so it will check whether it can able to predict the next character or not. Okay, so for that only we are getting the target is nothing but our output, so shifting over one character. Okay, shifting over one character. Then you will have one question in the end. Okay, if complete word is hello world means, for d what should come? Okay, for assume world is D has come. So for D, what should come like that? You will. So to avoid that, we will create some exception handling. Instead, for D, what we will do is we will give H as our value. Okay. So to avoid that error. Otherwise, it will take the next value. Okay. It is kind of looping, circle looping. Okay. Okay. So for this purpose only, we have created this try and except method. See, as I told, y is taking the next value of x. So it will continue until it reaches the end. Once it has reaches the end, it will throw some error. Okay, afterwards, after that particular character, there is no more characters present. In that case, we will pass y value as 0. Like 0th index means first value we will pass. Okay, and then here if you see means instead of giving return, I have give it as healed. So what is the purpose of giving healed is here normally when we are giving return or calling the particular function means after completing function, whatever local variable and their values will be erased from our memory, right? Whereas if you are giving this yield keyword means in Python, it will return from a function without destroying the state of local variable. Okay, whenever I'm calling the function again, it will continue with the last updated value in our local variable. Okay, so that is why we are using this particular yield instead of giving it as return. Okay, so um, so that is this particular function is all about. Okay, I will mention it. So why we are going for exception? To avoid indexing error in the end. Correct. So I will mention it so that you will also know when you are seeing why we are using this exception handling or anything. Okay, so let me run this particular function. Okay, so two functions, custom function we have created. One is for encoding, one not encoding, and then for generating batches we have created. Okay, this is just for sample purpose, example purpose only. So sample text I'm taking. Okay, from 0 to 19. Okay, from the beginning I'm taking. So I will run it and show. So this is my encoder value. So all are mostly going to be my space. Zeros will be like /n. Okay, and then if I'm trying to generate, okay, batch generation means, so batch generation sample text I'm passing. So here sample per batch is 2 I have taken, and the sequence length I have taken as 5. So based on that it will split the data, and then I can pass it to x and y. So now if I check my x and y value means, see here 0 is there, and here 50 50 50 is there, and here as we are having the actual value, we are not went to the end of the file, it is taken as 50. In case if it is an end of file, in that case it will again start from the 0th index. Okay, so uh, then we are checking for GPU. Okay, whether your if you are running it in local system and you think you are having a GPU in your system means you can check whether the kudu operation is present or not. Okay, kudu will be available only in NVIDIA graphics card only. Okay, in case if you are using different graphics card means you can go with CPU, or in Google Colab it will support this kudu operation. Okay. Okay, so here I am getting as true because I enable the GPU process. In your case, if you are not having GPU means you will get it as false. Okay, that is the difference. And I'm creating one LSTM model. So LSTM means long short term memory. Okay, it is also a kind of recurrent neural network. So normal neural network, what we have seen, I will erase this. Hope you all will remember normal difference between normal neural network and recurrent neural network. So in normal neural network, first will be having the input layer, and then it will be passed to some hidden layer. correct. And then it will go to the output. Okay, this is simple. So normal neural network. Whereas in recurrent neural network, each neuron will have the looping towards itself. Okay, that is the difference between normal and recurrent model. So what is the disadvantage of a normal recurrent neural network is, if the number of hidden layer is very huge, means it will take lot of time to process the data. Okay, predicting the next text will be very difficult. So to avoid that only, we will go for the LSTM method. So long short-term memory concept. Okay, that is also a recurrent model only. But here, what is the advantages? By default, the information will be stored for long time, long period of time. The information will be stored in our neural network. So by using this, we can use it for processing, predicting, classification. Okay, some time series model also we can able to perform using this long short-term memory model. Okay, so that is why here also we have taken this particular model. Okay, so here we are creating one class. Okay, character model we are creating. Okay, everything is customly created by user. Okay, we are not using any inbuilt or anything. Okay, so we are initializing. Okay, creating one init method, and inside that we are passing this self, all the characters. Okay, number of hidden layers you want, number of layers you want. Okay, here number of hidden is number of neurons, and then layer means number of hidden layers, and then drop probability, or a percentage you can also say how much drop should be there, and whether you are using GPU or not. Okay, by default we have given it is false. Okay, and then inside this we are setting the attributes. So whatever, just we are just calling this particular init method. Okay, and then everything we are initializing when the user is passing the value. If user doesn't pass anything, means we will take the default value. So here all character is the mandatory, means required attribute, others are default value they are having. And then we are creating some set encoder and decoder. So previously we have seen the code, right? So here we are putting it inside the dictionary. So that is the difference. So here all the characters we are passing into self dot all character, and then we are converting the dictionary format for decoding, and then reversing it for encoding method. And then we are having self.lstm. Okay, here anywhere I didn't create the LSTM, but LSTM is nothing but our model, actual model, which is present inside our neural network. Okay, nn.lstm, all caps. Okay, inside that we are passing the length of our all the characters, and the number of neurons, and number of hidden layers, how much drop should be there, and what should be my batch size. Okay, and then if I'm so we know what is dropout. So whenever it is doing one epoch, completing one iteration, so it will remove some neurons from our model, so that it will check whether it can able to still predict or improve our model. Okay, so that is why we going for the dropout. And then finally we are converting into linear method, or otherwise I will comment it so that you can understand. So creating our LSTM model, and okay, and finally we are converting into linear. Okay, for output purpose. And then we are getting another one. method called forward. Okay, inside that we are going to pass the x value, so which is going to be our training or predicting value, and then the hidden layer. Okay, and same things will be done. Okay, and finally we will get some output and as well as the hidden value. Okay, so this will happen when we are calling this particular, we will create some object for this particular class. From that object we will call this forward, and then we will call the hidden state. So here hidden state is why we have given is, in case if you are using GPU, means for that the hidden state should be different. Okay, we will be using our kudu method. Okay, it will increase our performance. Whereas if you are not using GPU and you are running it in CPU, means we don't need to specify the kudu method. Okay, and it's better to use GPU, otherwise it will take lot of time to complete this particular process. So kudu is nothing but a parallel computing platform. Okay, and along with PyTorch it can able to perform even more better. Okay, because it is dynamic computing. So finally we will pass the hidden value. So this hidden value will be passed here. Okay, that is how it will work. So I will run this particular class. Okay, up to this no doubt, right? So up to this we have just created, okay, different functions and classes we have created. So after this only we are going to create the instant of model, which is we are going to create an object and we are going to pass values to our class. Okay, here if you see, means I have taken the model equal to, so I have called the class character model. Inside that I have passed all the values. So all characters is all characters, like all characters means here whichever characters we have taken. And then hidden how many neurons should be present in my each layer is 512. Okay, by default value I have given as 256, but here I am passing as 512, and number of layers I want is 3, and then drop is 0.5, so 50% drop will be there each time. And here I am specifying is use GPU is equal to true. In case if you are not using it, you will specify it as false. Okay, if you are not giving also, by default it will take it as false only. Okay, so no problem in that. So I will run this, and then we are finding the total parameter. With total parameter it takes to run this um, model. Okay, here I have mentioned the note to be remember also. So try to make our total parameter to be roughly same magnitude of the number of character in our text. Okay, so for that I am taking the model dot parameters. Okay, it will return me some set of parameters, so I am passing that value to my total parameter. Okay, see, I am appending this to my list. So if I check the sum of my total parameter, means, so I am getting 54 lakhs 70,000 something, and length of my encoded text is again 54 lakhs 445, I mean 54 lakhs 45,609. Okay, so here again we are having lot of encoded text, right? So during the time of training, if I'm giving the entire data set for training, or taking 80 percentage or like that, means it will take again lot of times. So later steps I will try to take only 1% of my data set, and for that 1% I will give the training. Okay, so I am specifying what optimizer I am going to use, and what criterion I am going to use. So here I am going to use the cross entropy loss. Okay, previously we have seen various losses, right? So here entropy loss I am going to check, and then for optimization I am giving it as Adam. Okay, and then learning rate I am giving it as 0.001, which is default value only. So this you know, right? So here if you see, means I'm taking the training percentage as 0.1. Okay, but this itself will take lot of time when you are doing the uh, training time. So that's why we can stop here. So if you want, means you can increase the training rate and also check. Okay, and then now if I check, okay, this is complete length, and so out of this. I'm going to take only this much amount only, which is 5,44,560 text only I'm going to take in from 54 lakhs. Okay, even 5 lakhs is also a big number only. Okay, so and then for training index, I'm just multiplying. Okay, here I have checked, but didn't create stored it in any variable, right? So I'm creating one variable and storing it, training index, and then I'm creating in from that I'm creating some data for training and then some for validating purpose. Okay, so during the time of training itself, it will try to validate with new text and check okay whether validation is coming correctly or not. Okay, okay, so training data and validation data has been taken. So from uh, okay, here what we have done is in encoding text 0 to the training index, which means 5 lakhs we have taken for training, and from 5 lakh to remaining we have taken for validating. Okay, so based on the 5 lakh only it will process our data. Okay, and then okay, and now we are going to train our network. So for that um, I have created the variables whichever we are going to pass it into our model. So what we will pass, we need epoch counts, right? So here I have given it 50, and then batch size. So here I have taken 128. So you can take 64 or you can take 254, 512, anything you can take. As I told, it will try to multiply, I mean divide with the total number of text value. So based on how much value you are getting, I mean how much batch you are getting, so in that case it will try to pass. Okay, so and then some cutoff value will happen, everything we have seen in this previous function, right? So first it will try to do the encoding, okay, and remove the unwanted things, and then here, okay, after creating the batch count I have given it as 120. How much I have given? um, I have given it as 128. So total value will be divided by 128. So what value I am getting, that is going to be my batch count. And sequence length is, here I am taking it as 100. Okay, so for each batch, sequence of 100 character will be taken. Okay, and then tracker is nothing but usually we will use some count function, I mean count variable, right? Count is equal to 0, and each time it is running, the count value will increase. So similar way we are trying to give here it as tracker. So tracker is equal to 0, like that we are taking, and then we are specifying number of characters to be using. So maximum plus 1 we are taking, because 0 to like that we are taking. So now number of characters is maximum encoded text plus 1. Okay, so let me run this cell as well. Okay. Mm. And then we have to train our model, right? So model dot train is there. So setting our model for training, and again like simple check only if we are using kudu or not. Okay, in case kudu is enabled means we can add this kudu method. Otherwise, it will not do anything. Okay, and then for I in range of epochs. So how much epochs we have specified? 50. So 50 times this particular line will execute. And for hidden, I am calling the hidden state, which I have created, uh, customly created, right? So that is the hidden state. Inside that I'm passing the batch size. So what is my batch size? 128. So 128 will be passed there and some operation will happen. Those value will be stored in my hidden. Okay, then later on I will use this particular hidden variable, and here I am splitting x and y data by passing the generated batches. So train data, which is we have created here, okay, that 5 lakh data, and then batch size is 128, and then sequence length is 100. Okay, here as I told, it will try to track. So track is equal to, I mean each time it is looping, it will add tracker value. Okay, and then I'm doing the encoding. Okay, we cannot access, I mean process directly text, so we are converting into number format, and then we are splitting x and y. So x is going to be my input, so torch dot from numpy. Okay, because it is creating array. Okay, so it should be converted into tensor format. wait. Okay, okay, this particular line is running, so it should be converted into, wait, ah that should be converted into tensor format. So we will get input, and then for target also we are converting into tensor format. So if it is you are using GPU means, so we will add kudu for this particular input and target as well. Okay, otherwise it will skip this particular part and it will go to this particular line. Okay, here hidden tuple of state data from state in hidden. Okay, so and then finally we are trying to find the output. So LSTM output comma hidden. So how many hidden I have used and what is my output. So here model dot forward. So input and hidden I am passing, right. So input is nothing but my X data and hidden is my this particular information. Okay, this will be passed to um, this particular, we are calling this particular function, or we can call it as method because it is present inside my class. Okay, so it is taking lot of time. Okay, and it will also take, so initially it has started, see how much loss was there, it was 3.23. So slowly my loss is getting reduced. Okay, 3.21, 3.0, like that it will perform the 50 times iteration. Okay, this will be a bit lengthy process. And then here we are clipping the data. As I told, we will get some gradient error. Okay, so to avoid that we will remove the unwanted parameters. Okay, and then here we are doing the same thing for validation. Okay, we have split it into two offs, right? So X part completed. So for tracker, see here the tracker is helpful. So when tracker is divided by 25 is equal to 0. Okay, which means for every 25 iteration only you will see this particular output. See here 25, 50, 75. Instead of seeing everything, okay, you are seeing 25 percentage when it evaluated how much is my loss. 50 percentage completed means how much my loss. 75, 100, 125, like that. In, see, when zero step is there means this one process only happened. In my first step two iteration happen. In my second step again two steps. Likewise, for each step it will do some operation and it will try to find the loss. Okay, otherwise it will take lot of time to each step it is printing means it will take time, right. So for this purpose only we are creating this tracker. So for every 25 count it will print my output. So again it was taking x and y generation. So everything is going on. Otherwise I will put some comments so that it will be useful. So later on if you are seeing this code also you will understand what has happened here. Okay, here coming data. Okay, and then here tensor and adjusting for GPU if available. Okay, and then one more thing which we need to consider is this part. Okay, this part I have told, but I haven't explained it properly. Here, what we are actually trying to do is we are trying to reset the hidden state. Okay, so why do we want to reset this? Otherwise, for each what we have learned in previous examples and all, for each epoch, it will take the output data and pass it as input data, right? For increasing the optimization. But here that should not be happened. Okay, so for that purpose, every time when it running, it should start with the fresh data. Okay, that is why we are resetting our hidden state. Okay. Uh, Otherwise your prediction also will be getting wrong only. Okay. So, and we are using a recurrent neural network, right? So that itself will do the looping process, so we don't need to do that separately. So resetting the hidden state, if we don't do that means we would have back propagation. Okay. Okay, so then here, as I told, some clipping will be happen here. Okay, so to remove the extra data, some which is not fitting into our batch, something will be there, right? So those will be removed in this particular portion. Okay, so similarly here also doing the same thing. One not encoding will be done here. Okay, same, the steps and all same only, so I'm just copying it and checking. So validation, everything is going on. So it will take even more time. Okay, so that I will explain you the remaining steps as well. So here I'm giving some name for my model. You can give any name. So I have given as example.net. Okay, you should save it as .net. Okay, neural net. So that's the meaning. And here we have to give it as torch.save. Okay, if it's a TensorFlow means we will give it as tensor.save, right? So here torch.save and model.state. Okay, what in which state it is created our model. So that should be passed along with the name. Okay, so I will run this two line as well. So finally, okay, once we have created means if you are seeing the output means you will see example.net model. Okay, uh, even if you are doing in the project time also, we might have learned about pre-trained model, right? So this is how what they will do is they will create some optimized model. Okay, already they will give all the training, what the epoch count should be there, which for which particular epoch count, for which optimizer, which error direction. It is giving some greater accuracy, more than 95 or 97 it is giving. So they will create that, and from that model we can able to you can use into your project as well instead of creating it from scratch also. So that is one another advantage. Okay, once you have created this particular model means, so you can load this particular model into our program. So for that, only I mean important thing you need to be noticing is whatever value you have given during the training time, same should be given here also. Okay, so same hidden neural network, how many neurons should be there, how many layers should be there, drop count, GPU, everything should be same. Okay, and then afterwards we have created the model, right? Inside our model we will load the local state dictionary. Okay, it is stored in the dictionary format only here, right? So model dot state dictionary, so that will be passed here. Model name is example dot net. Okay, and then finally we will try to evaluate our model. Okay, how much it has been created, and finally we will try to generate prediction. So from start to end we haven't given any supervised learning, so we haven't told what should be my output, how should be my output, true or false classification, nothing has been done here. Only we have passed the x value. For y value it is we are just passing the next character value, that's all. Based on that it should try to predict the character, word, and then sentence, everything. Okay, for that again I'm creating one function. So whenever I call one method means, so this predicted text will be called each time. Okay, for next character. So how many characters I want 10 characters, 1 characters, like that we can specify here. Okay. Mm. So here if you come means, uh, so I have created the predicted next character. Okay, so if I given 100 means for each time it will check for the next character like that. Okay, finally it will stop once it has reached the maximum count. Okay, here encoder text is equal to model dot encoder character. So what we are doing here, encoding the raw data. Okay, encode raw letters with model, with our model. And then here we have to specify it in this particular dimension only. Okay, 2 dimension given, right? So first square bracket, inside that again I have to pass another square bracket. Okay, and then here again encoding, one not encoding is happening. In short I will give, and then conversion. Why we are doing it repeatedly means, there for creating the model we have given this. Now for converting the given text by the user, or here we are not going to give anything, but for uh, what to say, uh, for testing purpose, it will be again creating the text into some encoding format, right? So for that only we are repeating this particular step. Okay, so and then checking happening, hidden. Okay, resetting. Okay, wait. Collabs interactive. Okay, so same steps only coming here only. Okay, finally we are flattening it and finding the sum and choosing some random values from the index point. Okay, still my model has not yet completed. Only 12 epoch has done. So totally 50 epoch is there. Okay, so I will run it and keep, in case if completed means automatically everything will be completed. And then from this, okay, random choice, what will be my next predicted value, everything we have done. So final function is creating the text. So here text by each text here means what? Not by taking it as character, it will take it as words. Okay, word by word it will try to predict what will be my next word is going to be. Okay, like that it will predict. So I will evaluate my model. So here seeding value is the, so it will start with the, okay, it is my default value. We can also specify in from which character or which word you want to start your sentence or paragraph with. Okay, and your size means how many words you want, like that you can specify, and what is your model. Okay, like that it will create. Then what else need to be explained, and finally we will join the text here, word by word we are getting, right? That should be joined into single sentence or paragraph. Otherwise I will comment this also, will return string of predicted text. Okay, and output or character. So here we are appending the character which we have predicted, right? So adding the, or we can say predicted character. And here uh, what else? Hmm. Here see we are calling the particular function which we have created previously, predicted next character. So each time it will call this particular function, predict the next character for every character. So okay, that's all. Wait, I'll run this. So finally, if I call this particular text generate text, okay, inside that I'm passing the model and then how much size I want, and seed is I'm given as I. Okay, I can also give it as space if I give means based on this it will create one uh, it will create some since it is a Shakespeare's data set, it is having some what we will call play. That play kind of thing will be there in our data set, so it will return me like what Caesar told, what Julia told, something will be coming, so it will automatically create one play for us, okay, some with some introduction and then some conversation kind of things it will create. You can also give any random starting okay, from that it will start. So I think it is still taking time. Okay, so anyways, I'm going to give you this particular data set, sorry, particular Jupyter notebook also, so you can run it and check as well. Okay, so if you are changing any value, like instead of passing 10 percentage, you are passing different percentage, or you are giving different epoch count, batch size means you can um, change the model name and you can save it with different names also. Okay, so that is also possible. So this is one program, okay, like by passing some text value it is simply going to generate some random text for me. Another one program is there, so in that what we will do is if you are passing some text means it will return you the sentiment of the text, we can say it as category, like that we can split also. So this is the program. I'm not going to explain this program, okay, but I will give you this program. I have found it in the internet, so they have given the explanation here, and also in my PPT I have written this particular taken the screenshot of this particular code, okay, so you can check that also. So basically here what happening here is passing the data set, it is inbuilt data only, so text classifier which is present inside my torch text dot data set, okay, so I'm not taking any extra data here, okay. Based on that I'm giving some training to my model, okay. If I run this means it will take another 1 hour to complete, so I'm not running this. So final output alone, if you are seeing means here, if they are having 4 category, okay, whether it is a world news or a sport news, business news, science or tech news, like that it will give. You can add more category also if you want, and then here if you are passing some random value, I mean random text, taking from news, okay, it will try to predict whether it is a world, sport or business or science or tech news. Okay, it will predict and show. See here, this is predicting as this is a sport news. Like that, if you are giving some different value, different news means it will try to find whether it is coming under this any 4 category only. Okay, it will not predict something else. Okay, so this is one more program. So you can run this and check, okay, how this program has been created, how they have used. See here also they have used forward, weightage they have given. So a lot of things has been done here. Okay, and one more real-time application or 3D model creation and all, for we will use PyTorch method. Okay, so for that also I have taken one code. Uh, wait, I will show. If you want to say anything means you can put it in your chat section as well. Okay. Okay, this one only. Okay, again, I'm not going to run this now, but I have run and check, it is working fine. So basically what this particular model will do is, uh, if you are passing some data, okay, you can take any random image from the internet, okay, but make sure you take some full size image, okay, of a person. Um in case if you are taking, okay, here some video also given. Oh, okay, I will. So if you are passing some image to this particular code means it will create one 3D model like this. Okay. So here you can see this is a research paper, I guess. Okay. So first they are passing the image, or I will click here and show. Okay, see, here you can see it properly. So if this image has been passed to my that particular code, it will generate and give me the front as well as the back side of our model, like 3D model. It will create and give it to us. Okay, then later on we can use it for doing some animation and other things. So like that, they have given some example. If you want to pass means you can pass your image as well. So make sure you are giving full size image and with some ants and other things are visible properly. Okay, so that later you can do some animation effects also. Okay, so these are all they are saying taken from internet and try to create the model. So it is creating accurately. Okay, so it is trying to predict it. So similarly what I did, I tried to pass 2 3 images, it didn't come well. So finally I passed one image. So this is the image I took from the internet. Okay, png format. So this is my final output. If you see means uh, sorry, wait. So 360-degree it is showing. Okay, since the person image is not completely visible, so if you are seeing it in the front side view, it is looking better, right? But if you are seeing entire image means, see here and all some uh, not trained, I mean not created properly. So if possible, you can give some proper image. Okay, person standing straightly or okay, like that you try to give and check for this particular program. Okay, once you have created this type of model, okay, so if you go and check your folder means right now it is not showing anything because the connection has been disconnected. You will get .obj uh, format. Okay, you can open it and check in 3D viewer, which is by default available in Windows 10. Okay, so in the 3D viewer, you can see your model, how perfectly it has been created or any some error is there or not. That and all you can see. Once you have created, there is one website called maximo.com. Okay, so it is an Adobe product. So here, if you come here means it will show like sign up and login. I have already signed up, so it is showing like browse character or browse animation like that. Once you have signed up means here I'm just giving a browse character. Okay, here they will have some default characters. Okay, but here I'm not going to give any default characters. Instead, if you want means you can upload the character. Okay, I'm giving upload character. So select character file is there. So if I click means here I'm taken some 3D model which is already available. So Batman model I have taken. So the two obj object I'm having. Otherwise, I will open and show also. Wait, just a minute. Doesn't downloads. Okay. See, this is my model. Okay, which is pre-trained model. So this is how it is created. So this is one Batman image, obj image, and another one is
Sir, only your browser is visible.
okay. I think okay. Then I will share this obj image also. You open it and check in 3D viewer. Okay. I think some issue is there in sharing this particular window. Otherwise, wait, I will check. Stop and reshare. Okay, now visible, right? Okay, so here this is my model. Okay, so I can pass this particular model okay, to this particular website. So that particular program is completely written by using PyTorch only. Okay, So here I have taken this particular model, so it will come like this only initially. Next, so here we are to place the chin, wrist, elbow, knees and all proper position. They have given the instruction as well. So similarly, if you are placing it correctly means you can make this model to perform some live action. Okay, so chin part I have given here. Wrist here use symmetry is there. If you are giving symmetry means, so if you are placing in the right hand side means similarly for left hand side also it will automatically adjust. Okay, you should give it correctly, otherwise the output will come little bit different. And elbow, okay, I'm specifying elbow here. Okay, and then knees. Okay, and then center portion. Okay, so as per the instruction we have given, and then next, so it will try to reach our model. After performing this, we can able to make our model to dance or any other uh, animation which is present that can be able to perform in our model, and we can download it as well. Okay, okay, it has completed. You can use your see, it is just doing some. Here the problem is in the left hand side auto syncing is there, right? So if it is not correctly placed means, see, its hand is not properly coming. Okay, that alone you should take care of. Okay, okay, see, I didn't place the left hand properly, but other things, see, the knee, elbow, everything is passing correctly, so I can give some animation and change. Okay, I can make the model to dance. Okay, I can change the position, everything I can do. So later on I can download the model as well. Okay, so if you want me, you can also try with your own image and then you perform. Okay, so that's all for today's class.